So if we look at the steps that we just wrote down, step 1 said find the slope and find the y-intercept. Well, the y-intercept should be the easiest part for us to find. If we're looking at the y-axis, where is the y-intercept? What number is that on? Not 3. Negative 3. Good, because it's down here at the bottom. So we now know that the y-intercept is negative 3. But we also said we need to know what the slope is. Now there's a couple different ways we could do this. We could find the coordinates of 2 points and use our formula to calculate it. Or, since we have a graph in front of us, we can just count the rise over run. Since we have a graph, I think we should just count the rise over run. So from this y-intercept, how far up do I go before I go over? 2. So my rise is 2. And then how far over do I go? 3. Okay? Big question here, though, is should these be positive or negative? I went up and I went right. They're both positive, so we're going to make this a positive 2/3 for the slope. Step 2, we're going to plug this into slope-intercept. We have a slope, we have a y-intercept, so y equals m, our slope is 2/3 x, and then b is negative 3. We have now successfully created the equation for this line, but it's in slope-intercept. And we need to represent this in standard form. To illustrate what we're trying to accomplish here, I'm trying to take something that says y equals, and I want to turn it into something times x plus something times y equals one number. So let's start with this. In standard form, x and y should be on the same side of the equal sign. So can someone tell me how I can move the 2/3 x to the other side so that x and y are on the same side? They need to be on the same side of the equation for this to start out. Spencer?
Subtract 2x from both sides.
Not just 2x, 2/3 x. So I'm going to subtract 2/3 x on both sides of this equation. So minus 2/3 x minus 2/3 x. And what I'm going to end up with here is I have a negative 2/3 x plus y, because it was positive, equals negative 3. And we say, great, I did it. There's a problem with this. One of the things in standard form is that the coefficients have to be whole numbers, which means I somehow have to do something to this equation so that the 2/3 is no longer a 2/3. I need to turn it into a whole number. Any ideas? What can we do to this equation to get rid of the fraction? There's something we've talked about before that is possible here. James? Yeah, you've got the right idea. We're basically multiplying by the denominator. So I had a 2/3, my denominator was 3. James suggested multiplying by negative 3, which is fine. It doesn't matter if it's positive or negative in this case. But negative 3, we'll go ahead and use that. The thing we have to remember, though, is that if I multiply something, I have to multiply everything on both sides. So this is an equation. We have an equal sign in the middle. Whatever you do to one side, you have to do to the other side. It's not doing something to one piece and then another piece, which means I'm actually multiplying both sides of the entire equation by this denominator. Well, 3, or negative 3, is a whole number, so the 3 on top will cancel that 3 on the bottom, and negative times negative makes positive, and the only thing left there is a 2. Hey, it's a whole number. Perfect. Just what we were looking for. But I also have to do negative 3 times y, so now it's minus 3y. And I also have to multiply negative 3 times the other side of this equation. Well, negative 3 times negative 3 makes positive 9. This looks an awful lot like what I set out to do. I have something times x, something times y, and a number at the end. They are all whole numbers, which is part of standard form. I have all the things that I need. This has now accomplished what I'm looking for. I can double check and test this against the graph that I made. To find a y-intercept, I would take the number at the end, 9, and divide it by the number in front of y. What's 9 divided by negative 3? Negative 3. And there it is, the y-intercept. The x-intercept, I would take 9, and I would divide it by 2. What's 9 divided by 2? 4.5, 4.5. 1, 2, 3, 4.5. There it is. So I have all the pieces that I need to have. It's showing the same things on the graph that the equation is telling me here. I have an x-intercept that matches this. I have a y-intercept that matches this. Unfortunately, again, it was a longer process because we start with one thing and rearrange it to make another thing.